This video provides step-by-step instructions for you to create this bearing using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we will review the engineering drawings of this part called a bearing. We'll start by identifying the views provided in the drawings. This drawing shows 2 standard views used to describe the shape and size of this mechanical part. First, an isometric view shows the shape as a 3D pictorial to help us visualize the part. The orthographic view shows 2 principal views. In the lower left corner, the front view. Aligned directly above the front view is the top view. When preparing to make a feature-based model, we need to identify the basic shapes and features. The top view shows both ends are circular with the centers of both circles coincident to a horizontal center line. The diameters of the circles are equal and define the width of the part. The bearing end has a raised boss. Concentric to this boss is a bearing hole that extends through the part. A thinner mounting plate extends from the bearing end. Centered on the mounting plate is a slot with semicircular ends. All of the circle centers are coincident to this horizontal center line, and the part is symmetrical along this line. Next, we can read the size and information displayed by the dimensions and notes. First, the measurement units are in millimeters. The thickness of the mounting plate is 20 millimeters. The height of the boss is 60 millimeters. The distance between centers is 140 millimeters. The outside diameter of the boss is 100 millimeters. The inside diameter of the bearing hole is 70 millimeters. The semicircular end of the plate has a radius of 50 millimeters. The semicircular ends of the slot has a radius of 12.5 millimeters or a diameter of 25 millimeters. The distance between centers of the slot's semicircular ends is 70 millimeters. The material is a brass casting, and the mass units are set to kilograms. In this segment, we will review the design intent for the bearing. To start, we need to identify any features that might need to be changed or revised during or after the design process. We can anticipate that the overall length may need to be shorter or longer. We want to make sure that the center points of the circular ends are dimensionally constrained. And revising the dimension can change the overall length. The length of the mounting slot may also need to change. So again, I want to make sure that the center points of the circular ends are dimensionally constrained. And editing this dimension can change the length without changing its size or location. Next, we need to identify the features that should remain unchanged during any anticipated revision. In this case, the general shape and material thickness will remain the same. The sizes of the circular entities are unchanged. The thickness of the boss and plate. The part should maintain its symmetry. When creating the model, the choice and order of placing constraints will determine if the model will change predictively. And if the design intent is applied correctly, we can change the length of the mounting plate and slot, and the part will update without errors. Before we create this model in Onshape, let's preview the steps in our modeling process. Step 1. From the drawings, identify the profile or closed shape that we'll use for the base sketch. For the bearing, all of the information needed for our model can be captured in the top view. Step 2. Choose the desired isometric view orientation for the part in the Part Studio. We want the same orientation as the drawing, so we will place the sketch on the top sketch plane. Step 3. Choose the location for the origin to constrain the sketch to the plane. We will make the bearing end concentric to the origin. Step 4. Complete sketch 1. Step 5. Extrude 1 will create the base feature. Step 6. Sketch 1 can be used again to extrude the bearing, which will be added to the base feature and complete the part. create the base sketch. I've started a new Onshape document and named it Bearing. Before starting the sketch, I want to check my workspace units. Make sure the length is set to millimeters and the mass is set to kilograms. I'll start a new sketch in this part studio. Click on the top sketch plane. Use N on the keyboard to view normal and P to turn off the visibility of the sketch planes. From the toolbar, choose Center Point Circle. Click coincident to the origin to start the circle and enter 100 for the diameter. Click on the origin again to create the inner circle and enter 70 for the diameter. Hover at the origin and move to the right projecting horizontal. Click to create a circle. From the toolbar, choose the equal constraint. Click on the 100 mm circle, then click on the new circle to make them equal. Click on the Dimension tool and click on the center points. Set the distance at 140 mm. Next, we will draw the lines for the sides. These lines should be tangent to both circles. Click on the Line tool and then hover the mouse over the edge of the circle. Move it around until you see both a coincident icon and a vertical icon appear. Then click and hold the mouse button down to start the line segment. Hover on the edge of the other circle until both the coincident and tangent icons appear and let up on the mouse, snapping the end of the line to this tangent point. Repeat this process for the bottom line. All of the lines in the sketch should be black, showing that they are fully constrained. Use the Trim tool to cut off this extra part of the circle that is not needed. To create the slot, we will use a construction line to define its location and size. Click on the Line tool and the Construction tool. Click on the center point of the end circle and hold the mouse button down to draw a single segment. Stretch the line horizontal to the left and release the mouse. Enter 70 mm for the length. Click on the Slot tool, then click on the construction line. You can see the outline of the slot. Click the mouse to accept. Double-click on the diameter dimension and enter 25 mm. The sketch is complete. Use the green check to accept. Right-click and choose Isometric View. Create the base features. We can now create the base feature from the sketch. Click on the Extrude feature tool in the toolbar. This is going to be a new feature. For the sketch region, click on the regions of sketch 1 that form the mounting plate. It should be extruded up. Set the depth at 20 mm. This is our base feature. Next, we will extrude the bearing end of the part. Click on sketch 1 in the feature list to turn on its visibility. Click on the Extrude tool again. This time we are adding material to the base. Click on the region for the bearing. Set the height 60 mm. Accept the feature. The part is now complete. Check for accuracy. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass unit should be set to kilograms and the material set to brass casting. If the size and shape of your model was completed accurately, the mass should be 4.066 kilograms. Let's look at this process step by step. First, open the document that contains the model of the bearing. Next, check the workspace units and make sure that mass was set to kilograms. Next, set the material to brass casting. Go to the part in the parts list. Right-click and choose Assign Material. In this case, we're searching for brass casting. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 4.066 kilograms. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to find where you have made an error. First, locate the rollback bar in the feature list. We're going to remove extrude 2 and look at the mass property of only extrude 1. Move the rollback bar up to just below extrude 1. The mass is now 2.011 kilograms. If this amount does not match your result, check Sketch 1 or Extrude 1 for errors. Move the rollback bar to the end. The mass should now read 4.066 kilograms. If your result does not, check Extrude 2. In this segment, we will make revisions to the bearing. We will start by reading the revision drawings to find which features need to be changed. First, the length has increased by 40 millimeters to 180 millimeters between centers. Also, length of the slot has increased by 30 millimeters to 100 millimeters. When revised, all other features should remain as original and the part should remain symmetrical. You can check your revised part. It should have a mass of 4.621 kilograms. I know that the dimensions that need to be changed are in Sketch 1. So double-click to open it up for editing. Double-click on the dimension for the length and change to 180. Then hit Enter on the keyboard to accept the change. Next, double-click on the dimension for length of the slot and enter 100. To see what this change will look like, use the Final button to preview the result. Click on the green check to accept. With the revisions complete, let's check the mass properties now. It should be 4.621 kilograms. If your result matches this, you have revised the part accurately. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.